All right, here's our first part of 5-2 right triangle trig. A few snaps from the book. Their pictures will just be easier to follow than mine. So dealing only with the right triangles, we are working with SOHCAHTOA basically. So these first two pictures up here are just labeling the sides. So everything is based on the point of view of this acute angle theta. So my cute little angle theta. If I look at theta, opposite from it is this side. Adjacent is a fancy way of saying next to. And so that is right next to it. My hypotenuse will always, always, always be the longest side in the right triangle. And that happens to be opposite of the right angle. And even though it creates the angle theta where that adjacent side meets, so it's essentially adjacent to it as well. It has that special designation as being across from the right angle, being the longest side, and so that will always be the case. Now, the next picture I just included because this is talking about the labeling for each of them. So if this is angle A, across from A is my little a. So opposite A, and we can call it angle A or we can call it theta, would be little a. Across from B is little b. So again, the hypotenuse always being across from the right angle will be little c. And this is because we're going to need Pythagorean theorem. So a squared plus b squared is equal to c squared. So it's always the opposite side and the adjacent side are my two legs, and it'll be equal to the hypotenuse squared. So this might look a little overwhelming. There's a lot going on here with the right triangle definitions. Sine is opposite over hypotenuse. I always just wrote that as opposite over hypotenuse. So like OPP over HYP. Sine is opposite over hypotenuse, which again from the picture above is side A and C. Cosine is adjacent ADJ over the hypotenuse. Tangent is opposite over adjacent. And then all I'm doing with my other three, and maybe we're not as familiar with those, it's the reciprocal. So if sine is A over C, then cosecant is what that stands for. So CSC is my cosecant. Cosecant. The secant is the SEC. And so SEC stands for secant. And so they're partnered up like this because the sine is A divided by C, opposite over hypotenuse. And so my cosecant is flipped, and it's hypotenuse over opposite instead. Hypotenuse over adjacent instead, and then adjacent over my opposite instead for cotangent is what the last one stands for. So the cot is really my cotangent. So sine, cosine, tangent, I think we should be used to, and then cosecant, secant, cotangent. And then the word, my SOHCAHTOA, to try to help me remember which one's which. Sine is opposite divided by hypotenuse, and so that's what the S, the O, and the H stand for. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. It was never until we were using this text that I saw anything like the mnemonic device down below that some old hog came around here and took our apples. I just remember it with SOHCAHTOA. That reminds me of like a Charlotte's Web. I feel like it's on the farm with a bushel of apples. So whatever it takes to get you to remember. This is all I wanted to focus on today, because if you can't identify each of these, then what we do later becomes much more challenging. So this should be very quick recall to recognize when you're given the triangle, what's the sine, what's the cosine, what's the tangent. Cosecant, secant, cotangent, we don't use a ton, but once you have sine, cosine, and tangent, it's super easy to get those guys. So what we are going to do today, these are the book problems, and there are 8 of them in this first set, but I decided that we'll do 1, 3, and 5 together, And then you'll do 2, 4, and 6, and those answers you'll put in on your exit ticket. So the directions are to use the Pythagorean theorem to find the missing side first, and then to list each of the values. So really, the most work we're doing is figuring out the length of the side, and then it's just piecing all of those fractions together. So if I start with this, I'm missing my hypotenuse. And so I'm trying to find the hypotenuse, which is side C. And so my Pythagorean theorem for this one, right, hypotenuse up there, side C, is what I'm used to. So for number 1, it is going to be 12 squared plus 9 squared is equal to C squared. A squared plus B squared equals C squared. So that length is actually going to be, when I square root, that's going to be 144 plus 81. And these did work out to be whole numbers. So if you want to key that in your calculator, you can. It should be the square root of 225, which is 15. And so now that I have my 15, I have my 12, my 9, and my 15. And it's just a matter of, with respect to A, which is where my theta falls, what are all of these parts? So we already know that 15 is the hypotenuse. I think the easiest one after that is to go right across. And so if you go from theta directly across the triangle, then I know my 9 is my opposite, and 12 is the other one that is right next to it, just like the hypotenuse is. So I wrote them, instead of saying sine theta, I called it angle A. For the simple fact I wasn't sure if I could get a theta into our Google form or not. So the sine of A is simply 9 over 15. That is all you have to enter. Don't reduce the fraction. Don't use your calculator again to try to write that as a decimal point. It's much easier to find mistakes with these if we see exactly what the fraction looked like from the start, from the way the triangle was labeled. So cosine is adjacent over hypotenuse, 12 over 15. TOA, my tangent of A, would be opposite over adjacent, which would be the 9 over 12. Which you can also see, those are the numerators up above. The 9 is from the sine, that's the opposite side. Cosine is the adjacent side, so opposite over adjacent. The tangent is also written sometimes as the sine of the angle divided by the cosine of the angle. So, and then pairing these together, the cosecant of A, I just have to flip my 9 and 15 to get 15/9. For my secant of A, that's just my flip of my 12 and 15, so 15/12. And then the cotangent of A, if I flip that 12 and 9, it just becomes 12/9, which again, leave the 12/9 as a fraction, leave the 15/12 as a fraction, let all of that go. So 2 is exactly the same way. If you look at what's labeled and what's missing, all the same stuff. I'll actually do 3 down here so that we're a little bit closer to it. So the difference with 3, if I think of my parts, I don't have my opposite side. I have my adjacent side, and I have my 29 across from C, which is my hypotenuse. So this time when I am working with Pythagorean theorem, I would call, because opposite is across from angle A, that's my little a. So A squared plus B squared would be my 21 squared, is equal to my hypotenuse squared, which is the 29 squared. So I have to do a little bit of subtraction here to get that 21 squared to the other side. You can absolutely square these and figure out what their values are. I tend to just do it in one big step. So in my calculator, I would just take the square root of 29 squared minus 21 squared. And from that, I would get 20. Okay, so once I have my 20, over here is my opposite side. This, again, the sine of A, so opposite over hypotenuse is simply 20 divided by 29. cosine is adjacent over, so 21 over 29, and then TOA, my tangent, is opposite over adjacent, which again, if I look above, is just the 20 divided by 21. And then cosecant, I could again look back to it and recognize that that's hypotenuse over opposite, but since I already did all of the work in finding sine, cosine, tangent, I can simply use those fractions to just flip them. And there isn't, that I know of, a cute little mnemonic device about hogs and apples or otherwise to remember the cosecant, secant, cotangent. Okay? Messy, but done. The last one, and this will be very much like number 3. So number 5, this one, again, my 26 I see is my hypotenuse. This is my opposite side now, the 10. So I'm missing my adjacent side, which if I want to keep with my labeling and do that correctly, it's actually the little b. With Pythagorean theorem, it doesn't really matter which one you call the a or b, but we can just stick with it. So a squared, it would be 10 squared plus b squared is 26 squared. So this one again, I'm going to have to subtract that out, and then I'm going to have to square root this quantity, which leaves me with, I believe, 576. I think 26 squared is 676, and 100 squared, or I'm sorry, 10 squared is 100. And so we should get down to 24 for that adjacent side. So to finish this off then, my sine of A would be 10 over 26. And I could have found that without finding my missing side, but just doing all things in order. The cosine would be the 24 out of 26. And then again, once I have those, I really should be able to just rock through the rest of these. So the 10 over 24 would be the opposite and adjacent. And then cosecant of A would be 26 divided by 10. Secant of A would be 26 divided by 24. And cotangent of A would be 24 divided by 10. So now, again, all of this depends on the angle that we have identified. And so, since we just finished with this triangle up here, just very quickly, if I were to instead focus on angle B, then this becomes my opposite side, and this becomes my adjacent side. So if I were to find the sine of B, what is across from one is next to the other. And so that's my 24 over 26. So that's the sine of B while it was the cosine of A. And that's just a little preview of things to come. I believe in our next lesson, in the second part of 5.2, we'll take a good look at that. So otherwise, we did 1, 3, and 5 as examples. I want you to do 2, 4, and 6, and you are going to not have to submit the hypotenuse for me, but I'm going to ask you for sine, cosine, tangent, cosecant, secant, cotangent of all of those. So it'll be 18 fractions that you need to enter when all is said and done.